Hello, today we are going to learn about density and we're going to do a floating boats lesson and activity. Let's go on to the background information. What exactly is density? In simple terms, density is the amount of matter an object has in a specific amount of space. When we're talking about the amount of matter, we are talking about the mass of an object, and when we're talking about the specific amount of space, we're talking about the volume of an object. For example, if I have a feather that weighs only 1 gram and a rock that weighs 1 kilogram, we would know that the rock would sink in water while the feather stays afloat. So why exactly does this happen? Every object is made of atoms and molecules. An object with high density will have molecules that are more tightly compacted. This means that the rock is more compact and heavier than the feather. The rock has a higher density than water and the feather has a lower density than water. An object has a higher density than water will not float. This is a basic rule of thumb when it comes to density, and that is how scientists and engineers know how to construct boats and make sure that they do not sink. So what they do is that they measure the density of the boat, and if the density of the boat is lower than water, then they know that the boat will not sink. And it is still used in many experiments today, and we're going to do an activity surrounding boats and its density. So to summarize the scenario, the feather and the rock were both placed in a container with an equal volume of water. The rock had a higher mass, while the feather had a lower mass. The rock sunk while the feather floated. So density can be calculated by a simple formula. Density equals mass divided by volume, and the density units are usually measured in kilograms per centimeters to the power of 3. And so if we look closely into the density formula, we can see that there are two factors that affect density: mass and volume. So let's go back to the previous scenario and put it in mathematical terms. Since the volume was held constant, or stayed the same, for both the rock and the feather, it is not the deciding factor in the density equation. Since both of these are the same, and the volume is the same, we know that mass has to be the deciding factor to see why the density of the rock is greater than the density of the feather. The mass of the rock was larger, and it was 1 kilogram, which resulted in a larger density, and the mass of the feather was smaller, which resulted in a smaller density. Let's do a few small math problems involving the density formula so we can understand how density is involved in our activity later on. So let's go to number 1 first. What is the density of object 1 that weighs 45 grams and has a volume of 15 centimeters to the power of 3? What is the density of object 2 that weighs 60 grams and has a volume of 30 cm to the power of 3? Which object of the two is heavier and which object has a greater density? You can pause this video and work out these 4 problems and then press play when you are ready. So for question number 1, the answer was 3.0 for the density. So all you had to do was plug in the numbers in the density equals mass divided by volume equation, and that is 45 grams divided by 15 equals 3.0. The second one, again, was very similar. All you had to do was 60 grams divided by 30, and you got 2.0 grams per cm to the power of 3. So for number 3, we're going to ask which of the two objects was heavier. And since they gave us the grams in the problem, we can tell that object 2 was heavier since 60 grams is greater than 45 grams. Make sure that you realize the difference between heavier and density. Heaviness is measured in mass in grams, while density is measured by grams per centimeters to the power of 3 in this equation. So for our calculations, we see that object 1 has a greater density because 3.0 is greater than 2.0, and object 2 is less dense even though it weighs more. So as we can see here, the volume of object 1 was so small that it had a greater density. So if you want to have more practice, you can click on this website to look at more example problems. But for now, let's go on to the density activity that we have. For this floating boats activity, you will need aluminum foil, tape and scissors, a bucket of water, and 15 to 20 pennies. You can have more pennies if you would like. And the target goals for this activity is to create a sturdy boat that will float in a bucket of water while holding cargo, and the cargo is the 15 to 20 pennies that we talked about. And the second goal is to always have fun. So first, we are going to spend some time designing and planning how you want your boat to look like. Think about the density equation and lesson we previously covered to have the perfect design that you would like for your boat. After you finish your design, start the process of making it. Use the aluminum, tape, and scissors to make your boat. It does not have to be extravagant and can be very simple, but be creative and experiment with your boat if you want. Next, test out your boat to see if it will stay afloat by gently placing it in a bucket of water. Slowly add the cargo into your boat and see if it still stays afloat. You can add the pennies before you put the boat in water. Then repeat the experiment multiple times using different shapes for your boat because we are going to be looking at this in our reflection questions later. So these are the reflection questions. What shapes did you use for the boat, and which shape was the most successful in staying afloat with the cargo? How does the density apply to this scenario? Think about the density equation and the lesson that we talked about previously. Also think about the mass of your boat and how you added more or less mass in each shape that you made. Also think about the volume of the boat and the volume and mass of the water. Thank you for watching, and I hope you had fun.